Hey everybody, today we'll do another video. And today we will do some, it's called Introduction to trigonometry. Alright, so we do introduction to trigonometry, and basically what we're doing is we will try to do the basic of trigonometry functions and how they actually apply to angles, right? So basically, because when you're talking about trigonometry functions, it can be used in a variety of ways. But one of the basic things that we can actually use the trigonometry function is in angles. So what we can do is, to have a little foundation of how to use trigonometric functions, we start with it's called a unit circle, right? A unit circle is a circle that is basically a circle in the Cartesian plane x, y, z, what is also known as polar coordinates. So basically, this unit circle, right? It's based on the Cartesian plane x, y, and z. As you know, here x is positive. Over here, x is negative. Y is positive. Y is negative, right? So here, what the trigonometric function will be based on this unit circle, right? And what we know is the following. So we know that this here, like let's say for example that I start at some angle 0, right? And for me to start at some angle 0, I have to actually start somewhere in this line. Right here, right? So I start somewhere in that line, right? And that line, and I go around the circle counterclockwise, right? And notice that here the angle is 0, right? But if I start increasing that angle, the angle is increasing, so therefore it's getting bigger and bigger, right? So in the unit circle, that's why they picked the unit circle to introduce to make it 2 pi, right? So to be more making this short, right? So the full circle, or you can say full revolution in a unit circle equal to 2 pi radius. a full revolution around a full revolution in a unit circle equal to 2 pi radians. And we will explain how we get that, right? So I start here, right? I start here all the way to this point, right? Well, we can say that this is what? This is a quarter. This is a quarter of the circle, right? So right here, and I will explain why it's a quarter, right? Well, this is divided by 4 pieces, right? You can say 1. Actually, they have a name. It's called quadrant. These are called quadrant. So, quadrants. Right? It's called quadrants because if you think about it, you can actually form on a square of each of them. I mean, it's right. So they call quadrant, right? So this is known as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so now think about it. So right here I have I have the half a quadrant, right? And if the angle theta is somewhere here, and I am sweeping that across that first quadrant, this right now here is basically a half of the quadrant, right? So, and it is important to understand that each quadrant of the unit circle equals 90 degrees, right? So each quadrant of the unit circle is equal to 90 degrees. So therefore, this right here will be 45 degrees, right? Then here is equal to 90 degrees. And here is equal to 180 degrees. All right? Here is equal to 180 degrees. Here is equal to 270 degrees. And now, when I go all the way around, right, this is 270. So we get 90 plus 90 is 180 plus 90 is 270 plus 90 is 360. 360 degrees, right? Now, and we say that one full revolution around the circle is 2 pi, right? So, okay, so here is half pi is equal to 90 degrees, right? So, and then all over here is going to be, half pi is going to be 90 degrees, right? Pi is going to be here. And then when I get to here, it's a full revolution is 2 pi. And then also 2 pi is equal to 360 degrees. And I will do some conversion, how to convert, but not in this video, how to convert from radians to degrees. Now, the question will be, why are we doing this, right? That will be, the good question. Why are we doing the unit circle if we trying to learn trigonometry? Well, this is only the introduction. This is only the introduction because this is going to help us how to understand the trigonometric functions. Now, so now you can actually say that one full revolution around the circle is 2 pi, And also you can say that 2 pi, and also you can say that's equal to 360. The only reason why we use 2 pi is because with 2 pi we can work with the trigonometric functions better than the 360. But if you use the calculator, you can actually, if you have the mode in the if you set your calculator in degrees, you can actually you can also use degrees in your calculator, right? To do the calculations. Now let me erase this. And let me explain a little quick about the how this is used in trigonometry, right? We know that this is the Cartesian plane. This is basically XY coordinate, right? But we try to use this to come up, the mathematicians already came up with the functions, right? So, and they say that x is equal to function cosine of angle theta, and y equal to sine of angle theta. Okay, so look at this. This is x, right? And this is y, right? So now what if I get rid of this? I get rid of this line right here. And make another triangle like that. Now notice that this right here is, this angle is here right there. This is a right triangle because what? Because since it is a 90 degree, it's a right triangle, right? Now here you can actually see that the x is in that direction, which is positive, right? And the y is also positive, right? Now y is positive too, right? So if x represents cosine, that means that this is cosine of theta. And this right here is sine of theta, right? This right here is sine, you can actually, sine of theta, right? This component going up, right? So now let's analyze this, because this is going to be very, very important to pay attention. All right, so y is equal to sine of theta, and x is equal to cosine of theta, right? But then we have, altogether, we have 6 different functions, right? Now, 6 different functions. So we have cosine of theta, we have sine of theta, we have tangent of theta, we have cotangent, we have a cotangent of theta, we have secant, we have a secant of theta, right? We have cosecant of theta, right? cosecant of theta, right? Now, so this function, these are the 6 trigonometric functions that we have, right? Now, if you look at this quadrant right here, right? There are something that mathematicians already define. Also, it can be proved. It can be proved. Eventually, probably we'll do some trigonometric identities in this channel, but it can be proven. A lot of this stuff can be proven using the Pythagorean theorem. But, and I want to just, go by what is already there, right? So this, some of these functions are the ratios, right? For example, tangent are the ratios of other two functions. So tangent of theta is equal to sine of theta over cosine of theta. And why is that? And I will explain this little quick, right? So tangent is the ratio of sine over cosine, right? Okay, so here is sine, here is cosine, right? So the tangent is the ratio between these two functions, right? Now, if we look at this unit circle, right? I want it, before I go any further, I will put some symbol here. Here is positive, sine and cosine is positive. Here, sine is negative, sine is positive, cosine is negative, right? So sine is positive, cosine is negative. But here you got both of them are positive, right? Why? Because y is positive going up, x is positive going that way, right? Here, x is negative, x is negative, so cosine is negative, right? Sine is positive. Why? Because y is positive. Now, look at here. In the third quadrant, right? In the third quadrant, cosine is negative, right? Cosine is negative. And also sine is negative. Why? Because x is negative and y is negative. Look at here. Over here, cosine is positive and sine is negative. Now, you can actually make the list and write this down if you want to. Or you can actually just go by what you see, right? By visualizing, right? So you got it here, you got a positive, sine and cosine, positive, right? Here you got sine is positive, cosine is negative. Down in this quadrant, sine, cosine is negative, right? And also sine is negative. Here, cosine is what? Cosine is positive and sine is negative. Okay, so for that we have something that is called all student take calculus. students take calculus. Over here, all of them are positive. Over here, what is positive? What is positive? Sine is positive. Right? So over here, sine is positive. Then over here, you got over here, what is positive? Take, right? Tangent over here is positive. You know why? Because sine, over here, sine and cosine is negative, right? So if you put sine, negative sine of theta over negative cosine of theta, right? And that is equal to tangent of theta, of course. So that means that this one right here, if you cancel those out, right? Those negative go away. So then you got what? You got tangent of theta equal to sine of theta over cosine of theta. See that? So it's clear that here tangent is positive, right? Now, what about here? Calculus, right? Calculus C stands for what? It stands for cosine. It stands for cosine. And then if C is stands for cosine, then that means that here cosine is positive and sine is negative, right? But what is it telling me? That, well, calculus, right? It's cosine is positive, right? So that's why we use this, what is called all the students take calculus, right? So that can help you out to remember where the functions are positive and where these functions are negative. Where the functions are positive and where the functions are negative, right? So let me erase this. And we will do something that is called, now that we have this, so we know that over here sine and cosine positive, right? And also tangent is positive. Why? Because you know that sine over cosine is equal to tangent. No problem. Here what's going to happen? Tangent is negative. Why? Because it's a negative and a positive. Here we already found out that tangent is also positive because you got a two negative divided by a negative equals positive. Here, cosine is positive and sine is negative. Guess what? Negative by a positive is going to give you a negative. So tangent is also negative in the first quadrant. Okay, so now that we have that, now we have the unit circle, and we understand what the unit circle does in terms of trigonometry functions, right? We actually follow another one that is called SOHCAHTOA, right? So SOHCAHTOA, what it does is tell us the what each function does in terms of what are the values of the ratio of those values in terms of the angle, right? And let me try just to do the same angle and do it here so you can actually understand, right? Better. So let's say, for example, that this is do a triangle, right? So let's say that this is right. So now if I do a triangle, okay, so this right here, let's say that this is right triangle, right? So this is theta right there, right? Notice that here, this is the y-axis, right? So this is equal to sine theta. This is the x-axis, so this is equal to cosine of theta. And we will introduce something that is called the hypotenuse here. Hypotenuse. Hypotenuse. All right, so look at this. Look at this. And eventually we will derive some trigonometric functions out of this. But for the meantime, I just want to introduce this. All right, so look at this. What is the relationship between this, right? Remember from Pythagorean theorem that it said that a squared plus b squared is equal to c squared. So eventually we will derive some function, but now I am just doing the basic introduction that in this triangle, the sum of the two angles squared is equal to the hypotenuse. Okay. So this side right here is called, adjacent, right? All right, well, let's say that you put the angle right here. It doesn't matter whether it is the right triangle or not. It doesn't really matter. But this, let's say that you put the theta right here, the angle, right? Now, look at this. What is this? SOHCAHTOA. 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 What did that actually tell me? So, sine over the hypotenuse. No, sorry. Sine is opposite, right? Opposite over the hypotenuse. Cosine is adjacent over the hypotenuse, right? And then tangent is opposite over adjacent. Okay, so let's do this. So sine equal to what? Sine of theta equal to sine of theta is equal to opposite. What is opposite? This is opposite, right? Opposite over the hypotenuse, right? So sine of theta is equal to opposite over the hypotenuse, right? So opposite, you can put opposite like that over the hypotenuse. So right here. Let's see. Now, what is cosine, right? So we got that done, right? Cosine is adjacent. Cosine, right, of data equal to adjacent over hypotenuse. And then, so we got that done. So we got this done. Then we do tangent, right? Tangent is what? We know that tangent is the ratio between sine and cosine. So tangent of data equal to what? Tangent of data is equal to opposite over adjacent. Opposite and you can actually see right here that the tangent, the angle of, tangent is opposite over adjacent, or sine over cosine, right? Opposite over adjacent. Okay, so those are the basic foundations that we need to kind of start doing some trigonometry, proof or calculations, or maybe some trigonometric identities. But that's how you start. And eventually we will do, some proofs, right? Some identities. But for the meantime, that's what I want to do. I want to just do the introduction today of how trigonometric functions can be usable for different type of calculations. And electrical engineering, this type of functions are very useful. So basically, that's it. That's it for today, and thank you for watching. I will see you in the next video. If you like this video, give me a thumbs up, subscribe, and comment below.